Welcome to my video on experimental versus theoretical probability, red versus black cards. In this video, what I'm going to do is I've got a deck of 52 playing cards, and in that deck, half the cards are red and half the cards are black. This is your standard card deck, so you got the black and then the red. And the goal is to see how the experimental probability approaches the theoretical. So what I'm going to do is I'm going to count these cards one by one as I lay them down. And we know in the theoretical probability, half of them are black and half of them are red. So it should be 0.5 for the red and 0.5 for the black, half and half. Now, the previous video, which I've got a link in the back of this video too, I talked about the difference between theoretical and experimental probability. Theoretical is when you understand the situation and you can make a guess. Basically, you don't know for sure, but it's a very educated guess of what the probability is. It turns out to be correct. Experimental probability, you don't know exactly what's going to happen, but you're trying to figure it out. So you calculate the probability as you're going along. The number of red cards drawn divided by the total number of cards drawn. It changes with time as you draw more cards out. Okay, this is sped up by a factor of 2, so it didn't go that fast. But what it is, I've gone through the deck and I just sorted them out by black and red, and then I recorded the order in which I pulled them out. So you probably don't remember this, but it was black, red, red, black was the order. And then I went through all 52 cards and recorded that in a spreadsheet. And so that's what we're going to work on. That's going to be the data set to try to figure out how this experimental probability converges to the theoretical probability. Okay, these are the first 10 data sets that I took. So in this case, card number 1 was black, card number 2 was red, card number 3 was red, card number 4 was black, and on through all 52 cards. I just recorded each one. So that's the data set we're working with. Now I want to start analyzing this data set. So what I'm going to do, I looked at the first card, and the first card was black. So the probability, I'm going to calculate a running probability as I go through this deck. So the probability of the black is 1 divided by 1 because there's one sample. The sample space is 1. We had one event. We pulled out a black card. So that's 1 divided by 1 is equal to 1. The probability of a red card was 0. So the experimental probability tells us there's no red cards because it was a black card. Now we went to the second card. The second card was red. So now we have one black card and one red card in our sample space of 2 cards. So we get an equal probability of 0.5 for both red and black. Now we went to the third card, which was red also. So we still have one black, so 1 divided by 3 is 0.333, on and on. And the probability of red is 2 divided by 3, which is 0.666. So there's our probabilities. Now we'll do this for each one of them. So this is our graph of the running probabilities for red versus black cards. And so you can see the very first one we did was, it was a black card, so the probability was 1 for the black, 0 for the red. Then we went card number 2, which is right there. It was 0.5 because there was 1 red, 1 black. Now we went to card number 3, which is this point for the red. So we had 2 reds, 1 black, a probability of 0.666. And then the black card, we only had 1 out of 3, so that's 0.333. And so I said on and on. I kept doing this, and you see how the running probability, or the experimental probability, the more and more you do, we only had 52 examples in this case, it converges to the theoretical, and that's what it ended up to because there was 26 in the end, red, and 26 black. So in conclusion, experimental probabilities fluctuate early in the process. As more trials are completed, the results converge towards a theory. And this demonstrates what we talked about in an earlier video called the law of large numbers. The more experiments you make, the probabilities should converge to the theoretical if they do converge. I hope you learned a little bit about probability and saw this example. And thank you for watching.